Hey folks, very good evening and thank you for joining in. Could you please confirm in the chat window if I'm audible and visible so that we can get started with today's live session in a few minutes. Again, I'm just opening everything that we need to get started. So can you just confirm in the chat window if things are looking as they should ideally? Let me just open up the chat window here. Let me see on my phone also. Okay, sounds good, sounds good. So everything seems to be as it should be. Good, good. Okay, so we'll start in another 5 to 6 minutes. So any questions, feel free to ask me. I'll take some general questions for 4 or 5 minutes. And then we'll go into the live session, hopefully at 7:02, 7:03. And then I'll spend some more time at the end. So Gautam says, we tend to forget engineering math. Why? Like, I'm really curious why, because again, if you're thinking about formulae, I would recommend that most of the formulae, if not all the formulae in engineering math, can be derived from first principles, even in an examination setting, right? If you know the concept, it's fairly simple and straightforward to do it. At least that's how I do it very often myself when I solve engineering math problems. So what is it that you're forgetting? I'm really curious about that. So, okay, this is by Debjyoti, who says, I could not crack the IIIT PGE. I'm going to work at a services-based company. How to target GATE 2022? Simple. If you have already joined the company, try to make sure that you allocate fixed hours early in the morning and late in the evening, where you're going to give 100% of your effort to it. Again, you're now a working professional, no more an undergrad student. So you will have other responsibilities and deadlines and things like that. That's number one. Number two, in your preparation, try to make sure that you focus on subjects that you're a little lacking in the previous year preparation. That's very, very important. If there are some areas which you think you're not strong, first start with that and go to your favorite areas where you can score very well at the very end. So the order of subjects can change because you're preparing it for the second time. That's what I would recommend. Again, somebody is asking about taking some time while solving some problems in operating systems or other subject. Don't worry about it. Try to get answers correctly. That's what is important at this point. Like, you can worry about speed probably from November or December. Now worry about getting accurate solutions. That's what matters more. Get conceptual clarity, build the problem solving ability. Speed has never been a very important factor in GATE, unlike other competitive exams, right? So accuracy is more important. Conceptual clarity is, you will get through speed, the little speed that you need, you'll get it through practice. That's not a problem that you have to worry about. So this is from Srivatsa, who says, how to remember after the first iteration. Again, I'm hoping that even within the first iteration, when you're going through the subjects, I'm hoping that you're doing the weekly, monthly and quarterly revision. So you're already doing 3 revisions as part of the first iteration itself, and you're solving good chunk of problems. So at the end of first iteration, revise all the subjects once, start taking things like grand tests and things like that, or solve whole previous year question paper end to end, right? That's a great form of revision and also practice as part of your second iteration. So within the first iteration that you're learning, make sure you're doing weekly, monthly and quarterly revision. That's more or less mandatory. So somebody is asking, what is the best resource to learn semaphores in depth? Again, you can pick up any standard textbook for operating systems, Shilbert Galvin, any standard textbook, right? Not Shilbert Galvin, Galvin basically. Shilbert Scott is another textbook, right? Pick up any standard textbook. It has enough material that you need for GATE. Any standard operating system textbook. Pick any of it. Any standard textbook that you have in your coursework. 99% it will cover everything that's needed for GATE. Again, there is no point going very deep into semaphores because GATE is not so much about depth. If you want to go that deep, you can always pursue operating systems and distributed systems as part of your master's program, and you can become expert at it at that point of time. Yeah, so it's 7:01. Let's wait for a couple of more minutes. I'll take one more question and then we'll go into the live session itself. So this is a question from Sneha, how to prepare MSQs for GATE. Again, unfortunately, in the previous years, there aren't enough MSQs. So even in our test series and things like that, we are adding more and more MSQs. Of course, designing MSQs takes more time. We have started them last year itself as soon as MSQs were announced. This year, we are incorporating more MSQs both in our test series as well as in our whole course structure itself. Again, it takes time. I mean, because we've already created thousands of MCQs and numerical answer types. Creating more MSQs typically take like at least 50% more time to create because you have to think of all the options and be careful when you do it. But MSQs also don't tend to be very hard in general as compared to, let's say, other types of questions. They try to test mostly your breadth of knowledge. So again, even if you can solve MCQs and if you don't do silly mistakes, I think you can solve most MSQs gracefully. We have not seen students having specific problems because of MSQs alone. Okay. So with that out of the way, let's get started. Since it's 7:02, I'll start sharing my screen. Can you please confirm if you can see my screen clearly so that we can get started with the live session itself? So can you please confirm that? I will start the live session as soon as we are clear. Okay, everything is okay. Just confirm about the screen. Yes, it's visible. So let's get started. So today's live session is the 6th live session in data structures algorithms. It has a bunch of topics like MSTs, shortest paths, greedy and dynamic programming. Again, while dynamic programming and tree traversals are very important for interview preparation for top product based companies, not so much in GATE, right? Because GATE, you don't write code as much. Right, so we have the 7th live session, which is the next live session where we discuss about data structures and algorithms, which is on the coming Friday, about how to prepare data structures and algorithms from an interview perspective. So with this, we will wrap up the GATE specific preparation for data structures and algorithms. Okay, cool. So let's get started. Here comes the first question. Okay, so everything is visible, right? Okay, so yeah, the full question is visible. Please take a shot at it. Please read the question very carefully. Please read the question very carefully. This is a slightly different type of question as compared to what you typically see in the previous year questions in GATE. Slightly different format. Be slightly diligent when you're solving this question because it's of a slightly different type as compared to typical optimal schedules that you solve. Take your time, it's okay. This might take a little time to get the answer correctly and carefully. It's okay. I already see multiple different answers, so please revisit your answer. Again, if you know the concept of how to solve typically optimal schedules problem, this is straightforward, but it's slightly different format. Okay, I'll wait for a few more seconds for others to answer, because I'm sure a lot of you are still tackling this question. Please recheck your answers, because I see a good chunk of errors in this. So please recheck your answers. Again, some of these topics could have slightly time-taking questions, because you have to go through this whole table and then do a bunch of steps. But these questions are not hard. I mean, this question would be sort of like a typical medium level question by gate standard. It might take a few minutes, but the concept itself is simple. Good, good. I see people who are taking little more time getting the answer correctly, because I'm assuming they're being more careful here. I see typically 3 answers, 4, 8 and 12. Okay, so let me just solve it in the interest of everyone's time, so that we can move to other questions. Again, there are also some lengthy questions little later. So this is like a typical optimal schedule problem, and the steps, you basically use a greedy algorithm for this, right? And what are the 2 steps? You first sort in decreasing order. I'm just writing the basic steps, right? So you sort by decreasing profit, right? Because you want to maximize profit. And then you place any task as close as possible to the deadline, right? So you try to schedule a job, right? Schedule a job as late as possible, right? As late as possible within the deadline, right? So that's the basic greedy strategy. So to solve this problem, we typically use a Gantt chart, right? So how does a Gantt chart look like? So imagine I have time here, and let's assume I have the task ID, right? And I have, let's say, profit here. Okay, so first let's sort everything by profit. Which has the highest profit? This has the highest profit, and its deadline is also 1. So I have my time 1, 2, 3. If you look at all the deadlines, 1, 2, 6, right? 1, 2, 3, 4, 5, 6. These are the times that I have. So this will be my Gantt chart. My Gantt chart will look like this. Again, I'm also solving it right here, just because I want to keep looking at this table while I solve it. Okay. So, okay, so I have 6 time slots and okay, so the one with the highest profit 33. So I will just place it here and this is task 7. So task 7 is completed and its deadline is also 1. So we place it here because you can't place it any other place. We're just using this greedy strategy. Now let's go to the next highest profit. The next highest profit is between 21 is here. Is there any other 21? There is also a 21 here. So it could be either task 1 or task 8. But look at the deadlines now, okay? Because the profits are the same. Unfortunately, the deadlines are also same, which means in this slot, I can either place 1 or 8. Look at this. I can either place 1 or 8. I can't place both, right? So this is or 1 or 8. And if I place 1 here, I cannot place 8 anywhere because I would cross the deadline, logically, right? So I have 2 possibilities here. So if you think about this, in the second time slot, I have 2 possibilities. 2 possibilities. I can pick either 1 or 8. Now what about, okay, so this is also now resolved because once I place 1 or 8, I can't, suppose if I place 1, I can't choose 8 and vice versa. So which is the next highest? Now let's look at it. So next highest number here is 17, right? There are no other 17s here, right? So this is task 6. Task 6, 17, its deadline is also 3. So this is also taken care of, right? Okay. So this is resolved. Now, which is the next now? Next we have is, okay, 16, right? So next we have is 16 here. Its deadline is also 4. So let's place profit of 16. The task ID is 10. Okay, so this is also resolved. Okay. So next, what is the highest now? The next highest that we have is, let me look at it. So you have, so 14. You can't place 14 anywhere. Again, 14 has a deadline too, but you can't place it anywhere because that time has already passed. Now after 14, what do we have? We have 12 here. 13 is there, sorry. We have 13 here, but 13 also has a deadline of 4. So we can't place this anywhere. Next, what we have is 12. Now 12 has a deadline of, one second. So 12 is here, 12 is here. This 12 has a deadline of 2, so we can't place it anywhere. There is 12 here, there is 12 here. What are the deadlines? 5 and 5, right? So we have 2 deadlines here, 5 and 5, which means I can place either task 4 or task 9 here. So task 4 or task 9, and I get a profit of 12. So these 2 are also resolved. Finally, I am left with these 2 tasks, task 5 and task 12, both of them having the same profit, the same deadline also. So which means at 6, I can either place task 9 or task 12. Sorry, task 5. I'm sorry, my bad. Just a second, not 9. This is task 5, 5 or 12. I'm sorry, 5 or 12. Okay, and I would generate a profit of 10. All right, simple. So if you notice, in the second times, in this time slot, I can only place 1 task. In this time slot, I can place one of these 2. In this only 1, in this only 1, in this I have 2 possibilities here. Here also I have 2 possibilities. Simple. So what are the total number of possibilities here? 2 into 2 into 2, which is 8 possibilities. That's what most of you got as the answer. Simple. This solution might take a little time to solve because you have to go through this table and fill up this whole Gantt chart, right? Filling it up takes a little time, but it's a simple, if you know how the greedy approach of job scheduling works, this is more or less straightforward, right? Simple problem. Not much of combinatorics also. This is simple, like number of possibilities. This is like high school combinatorics, right? Simple problem. But it's a very different type of problem as compared to what you typically see in GATE. Again, this is inspired from a lot of assignment and final semester exams at top universities. This is also created by one of our mentors, mostly from scratch, and again, interesting type of problem that you could get in the future. Cool. So let's go to the second question now. This is a very typical GATE type problem. Again, you encounter a lot of combinatorics everywhere in data structures and algorithms when somebody wants to ask that counts, right? Because that occurs a lot in discrete math. This is a very typical gate-like question. Again, please be careful with this. Some of these questions might take time, but please be diligent, follow the steps. Let me write it here. Take your time. Take time, follow the steps. And don't make silly mistakes. And no silly mistakes. That's it. That's all you need. This is like a typically good 2 marks question in GATE. Good, good. I already see people putting in their answers. Very good. I mean, you're pretty fast at calculations. Good to see that. This is how typically DP problems are asked in GATE. Take your time, it's okay. Those of you who are still solving it, it's okay. Please take your time. I'll wait for you. This is, okay, I'll come to whether it's easy or medium in a couple of minutes. So by GATE standards, this question will be considered as easy because, I mean, if you know optimal matrix matrix multiplication, this is straightforward. You apply what you already know and you solve it, right? There is nothing tricky. It might be a little time taking. That's all, right? The reason typically 2 marks could be awarded for a question like this is because it's an NAT and it is time taking. That's all. That's the only reason. Right? Again, if you're not careful, you'll make silly mistakes. That's another thing that you have to be slightly careful about. Cool. So, okay. So let's answer this question, right? So what is to compute A, B, C, D, right? How do you solve it? This is a standard DP problem, right? You take the minimum number of multiplications that you need with multiplying A with BCD right? That's one way to parenthesize this. The other way would be AB into CD, right? So whichever takes fewest number of multiplications, you take that as the answer. The other option is ABC multiplied by D. Now here if you observe, AV is a 2 cross 3 matrix, right, given here. BCD is 3 cross 4. B into C into D is 3 cross 4, right? So this will be a 3 cross 4. AB is a 2 cross 4. It's always helpful to write these dimensions to avoid silly mistakes. So CD is a 4 cross 4. I always write the dimensions of matrices to avoid silly mistakes. ABC is a 2 cross 2 matrix. D is a 2 cross 4 matrix. I always write this just to make sure that I'm not making some silly mistakes, because this question is prone to silly mistakes. Okay, to solve this whole thing, we obviously need more information on what is the best solution for BCD, how many multiplications are needed for AB, and so on and so forth, right? So let's write down BCD, right? Because you have BCD and ABC. For BCD, it will be minimum of BC into D. This is one option. The other option is B into CD. There are two options here if you think about it, right? So again, let's fill in the dimensions. I always write the dimensions to avoid silly mistakes. BC will be 3 into 2, right? So your D is 2 into 4. Your B is 3 into 4. Your CD is a 4 cross 4. I always write this. I recommend you also do this. Again, I know this is a lengthy process, but this will avoid silly mistakes. Okay, so then you have ABC. ABC will be minimum of AB into C and A into BC. Again, same steps. You just have to follow the steps. AB is a 2 cross 4 matrix. C is a 4 cross 2 matrix. A is a 2 cross 3 matrix. BC is a 3 cross 2 matrix, right? So now you have broken this BCD and ABC, right? You can also compute that recursively. This is like a recursive computation, right? Again, you're doing top-down recursion of a DP problem. Basically, that's what you're doing here. Now, if you observe, we have BC, AB, CD. Okay. So we also have AB, right? So how many multiplications are needed for AB? A is 2 cross 3, B is 3 cross 4. So the total number of multiplications will be 2 into 3 into 4. So it is 2 into 3 into 4, that is 24. Similarly, we also need for BC, because we need BC here, right? So we need AB, BC and CD, right? So for BC, what you do? What are the number of multiplications that you need? 3 into 4 into 2. 3 into 4 into 2 is also 24. It is same as 2 into 3 into 4. So what about CD? CD is 4 into 2 into 4. 8 fours are 32. So you have some of the details here, but the game is not yet over, right? So this part we have it. Now let's start filling in the details, right? So let's fill in for this. So this is BC first. You have to compute BC. BC already has a cost of 24. To compute BC, you need 24 multiplications plus 2 into 3 into 2, right? So if you write 2 into 3 into 2. Now what about this now? This is AB. What is the cost of AB? AB cost is 24 plus 2 into 4 into 2. 2 into 4 into 2. So if you observe, 24 is the same. This is 2 into 4 into 2. This is 2 into 3 into 2. So obviously this is going to be cheaper. So this is 3 2s are 6, 6 2s are 12. 12 plus 24 is 36. So this costs 36 units or 36 36 multiplication operations. So ABC is 36, right? So to compute ABC, you need 36 multiplications. Similarly, you compute for this also. What is BC? BC is 24 plus 3 into 2 into 4, right? 3 into 2 into 4. Similarly, CD. CD is 32. 32 plus 3 into 4 into 4. Now, obviously, this is going to be smaller, right? This is much larger, right? Because this is larger, this whole product is smaller than this whole product. So if you simplify this, you will get it as 48, right? You will get 48 from this, because this whole thing, 4 2s are 8, 8 3s are 24, 24 plus 24 is 48. So for BCD, the cost or the number of multiplications is 48. Now let's work out so we are solving, we got the smallest. Basically, we recursively went top down in the DP. We are now coming bottom up now, right? Now let's see, what is the cost of BCD first? BCD cost is 48. 48 plus 2 into 3 into 4. Right? Similarly, what is the cost of AB? AB cost is 24. CD cost is 32 plus 2 into 4 into 4. right? So 2 into 4 into 4. Now what about this? What is the cost of ABC? ABC is 36 plus 2 into 2 into 4. Now if you observe, this is smaller. This number is also smaller than this. This whole thing is larger. So obviously this will be the smallest. 4 2s are 8, 8 2s are 16. 16 plus 36 is going to be 52. So the answer here is 52. All we have done is, we have started with the bigger problem. As long as you know how the DP formulation itself works, you just step by step go back and solve it. That's all. It takes a few minutes of time, but this is easy question as long as you avoid silly mistakes, because there are so many 2s, 3s and 4s. It's very easy to mess up the math at one place and everything goes for a toss. So this is an easy question, but you have to be careful and it's time taking, and hence this is typically like a 2-mark question in GATE. Typically, not always, but typically. Okay. But this is the type of DP problems that you encounter in GATE. Cool. So let's go to the third question now. Okay, the question is visible. Okay, cool. This is an MSQ. We will surely answer the general questions at the end. Let's solve the problems, because some of these problems are lengthy. We want to solve them first before we go to the general questions. I'll surely answer that. There are some follow-up questions that our mentors have answered. This is also a very, very nice MSQ about graphs. Very typical of GATE, but we have formulated it into an MSQ format. There is no partial marks awarded for MSQs. You either get full marks or you get 0 marks. There is also no negative marking for MSQs. Again, this is common across almost all competitive exams across the world, except for a handful which give partial marks. But in most competitive exams, you either get full marks or 0 marks. I see some of you already putting in your answers. Please revisit your options. Please don't be in a hurry to answer a question and get it wrong. I see some of the people who are answering very quickly, making silly mistakes. Trust me, they'll cost you very dearly in the exam. I know that they're silly mistakes because I see the silliness in the mistake also. It's clearly evident. This question is easy and scoring. This is like a good 2 marks question, and by GATE standards this could also be considered as a medium problem, but medium but straightforward, nothing tricky about it. I'm happy that some of you have corrected your answers. Good, good, good. Good, good, good. Some of you, I think, only have a little confusion, but we'll solve it together. Okay, so let's solve it anyway. So, okay, so you're given this graph, this weight is missing, it's called X. Now we have four options. First, let's read through the options. The maximum value of X such that edge BE is present in every minimum spanning tree is 10. The second option is the maximum value of X such that edge BE is present in every MST is 9. Okay, so only one of them can be correct. Right? The next thing is the number of MSTs for the graph with BE as part of the MST is 16. The same thing, 28. So only one of these also can be correct, right? It could be such that some of them, both could also be false. That's possible, right? So let's go step by step. Now let's look at these two first, right? So again, look at this. These four have the same weight. These four have the same weight, and those weights are the smallest. Now, if you observe these three edges, X, 10 and 12, they form like a cut set, right? They're basically cut edge set, right? Which means at least one of them have to be there in a minimum spanning tree to span all the vertices. For example, here if I take these three in my minimum spanning tree, and if I take these three, I need to take at least one of these in my minimum spanning tree. That's because it's a cut set, cut edge set. That's what I mean, not a vertex set, but an edge set. Now, which means if you want your X to be present in every MST, then your X has to be strictly less than 10 and your X also has to be less than 12. And it is given that consider the following undirected weighted graph where weights are positive integers. So which means X can't be a real number. So the maximum value of X is 9. Because if this is 9 here, because you have to pick one of these three, right, to create your MST, if this is 9, you would actually pick this. Simple logic. And you would not pick this because you want the spanning tree to be minimal. Right? So simple. So with that option, B is the answer. So A is not the answer because if this was 10, then you could have also picked up DG. So if X was equals to 10, then it need not always be there in the minimum spanning tree because I have two options to pick and I can go ahead and pick DG instead of BE. That's why if you want it for sure, it should be present in every MST. 9 is the answer. Now let's look at the number of minimum spanning trees. Right? It's actually fairly simple. When you're trying to construct a minimum spanning tree, look at this. All these weights are the same and they are the smallest. These weights are also the smallest. So if you look at it, this is, if you think about it logically, right? So this is one subgraph. This is another subgraph and they have the smallest weights. So within these four edges, let's ignore these three. Let's ignore these three edges for a couple of seconds. Okay. So if you look at this subgraph with only these four edges, you can pick any three of them to connect these four vertices. So 4 choose 3 because the weights are the same. Remember, the weights are the same because in an MST, if the weights are same, you can pick any three of them in this left part. So 4 choose 3 is 4. So which means in this left sub part, you can choose any three edges. Any three edges in 4 ways. Number one. By the same logic, you can also pick any 3 edges within these 4 edges. Between these 4 vertices, there are 4 choose 3 ways, which means there are 4 ways. And again, when you're building an MST, you'll start with the lowest weighted edges, right? That's the algorithm for constructing MSTs, right? Now let's assume just for simplicity, you picked this, and let's assume you picked this. This is just one example. There are basically four possibilities here, 4 possibilities here. Now, this subgraph and this subgraph are not connected, so it's still not a spanning tree. Right? So to make it a spanning tree, you need to pick one of these 3, right? So now, when will you pick the number of MSTs with BE as part? Now, if you want BE to be part of it, obviously this weight X or this edge weight X has to be less than equal to 9, right? Simple. So that's what we want. We want the BE edge to be part of the MST, right? So it could be any integer value, but it will be one unique integer value, which means how many MSTs are possible? I can choose I can choose edges amongst these 4 vertices in 4 ways. Amongst these 4, I can choose in 4 ways. Now between these 3 edges, I need to only pick one to build an MST. So there is only one way, because I want my edge BE to be there in every MST. There is only one way here, 4 ways and 4 ways. So total 16 ways. So option B and option C are correct options. Again, not some complex combinatorics. This is simple, like this is very, very simple stuff. It's not, I think some of you are confused. I think some of you are saying 2 into 4 choose 3. No. It is 4 choose 3 into 4 choose 3, because there are 4 ways of picking here, or in other words, 4 choose 3 ways of picking here. There are 4 choose 3 ways of picking from this. That's basic combinatorics, right? And one way of, there is only one way of, because once you pick this, you don't have to pick these 2 edges anyways, right? So BE, again, the question says BE as a part of every MST. That's the question, right? So simple, 16 is the answer, straightforward. Okay, cool. Is there a problem? Okay, so anyway, some of our mentors have answered the follow-up questions, but this is the thought process behind it. Okay, cool. Again, some of you might say, hey, what if X equals to 10? Then it may not be there in every MST. Don't forget that. See, we want BE as part of the MST, which means this X has to be less than equal to 9. Otherwise, it may not be there in some BSTs. That's a constraint that we have. Okay. Again, some of you may have done a silly mistake, so just be slightly careful here. It's a simple, straightforward question. It's medium by gate standard, typically a 2-mark question. But if you know the concept of how to compute MSTs, this is straightforward. Cool. So let's go to the 4th question now. Again, please be careful when you read these options. It can be slightly confusing with the parenthesization, so please be careful. So Swapnil, to answer your question, I think DP and graphs are already there in our data structures and algorithms notes. So see both the notes, because it could be split between data structures and algorithms, right? Because DP is typically part of algorithms, not data structures. So it will either be in data structures, or if there is one notes for DSA, it will be both. Anyway, let's get back to the question. Take your time. Please be careful. Again, a very typical gate question. Again, you're most welcome to post general questions about other subjects at the end of the discussion. We'll try and answer as many as possible. Good, good, good. Somebody saying B and C are the same option. No, please be careful. That's what I told you, right? Please see the parenthesization carefully. They're not the same, obviously. Look at basic parenthesization. And none of the above can also be an option here, right? So you have to be careful. This is a very typical gate question. Okay, most of you got it right. Some of you may be slightly confused here, but most of you got it right. So let's answer this, right? So how do you get the optimal merge pattern? It's very simple. At any point of time, merge the two smallest files, right? The two smallest files is the simple merge two smallest files at any time, right? That's a simple, this is a standard greedy strategy, right? So you just apply that to the problem at hand. It's as simple as that. So which is the smallest files first? F3 and F5. Right? So let's merge F3 and F5. Right? So they're done. So when you merge both of them, you get a size of 25. Right? So this is done, this is done. Now what do you have? You have F1, F2, F4, F6, F7 and the combined F3, F5 which is 25. Don't forget that. This is also a file that you have to merge with the rest of them. Right? Now what are the next two smallest? The next two smallest are F4 and F2, right? F4 and F2, right? So F4, F2. So F4, F2. Now when you merge both of them, F2 and F4, you get a size of 19 plus 17 would be 36, right? So now you have F1, F6, F7, F35, F42, right? Now which are the two smallest? F1, F7. Okay, let's write that. F1, F7. Now, when you merge both of them, what do you get? 23 and 27. That will be 47, right? Next, what do you have? You have something as file of size 50, file of size 47, 25, 36. So you pick the two smallest. These two will be the smallest, right? So when you merge them, you get F3, 5, 2, 4. You merge these two first, right? When you merge these two, what do you get? You get a file of size this is 50, 61, right? Simple. Then pick the next two smallest. 47 and F6 is there, don't forget that, right? So this will get merged with F6, right? So F6 has a size of 50. So 50 plus 47 will be 97. Finally, these two will get merged. That's the strategy. So now let's try to eliminate options or think through. So if you observe, it doesn't matter whether I do F1, F7 first or F3, F5 first or F4, F2 because they're three independent things. They're not dependent on each other, right? So if you see option B here, what is it saying? It's saying F2, F4, F3, F5. Okay, so these two. So it is first doing these two. Again, whether I do this first or I do this first doesn't really matter in terms of doing the optimal merge pattern because they're independent stuff. So the order in which I write doesn't matter here because this will be done independently, this will be done independently. Now if you see the parenthesization, once this is done, look at this, once this is done and this is done, the parenthesis shows that now we will do this. Now we'll merge these two and that makes complete sense. We're merging these two now. Then it says F1, F7. Look at this parenthesis, F1, F7, right? Once you have F1, F7, then you're merging that with F6, exactly as shown here. Then finally, this resultant and this F6, this is basically F617. So this final thing and this final thing are getting merged in this bigger, the last parenthesis. So if you see the parenthesis carefully, B is the right answer. Some of you probably got confused and said D is the right answer because you might have thought, hey, shouldn't we be doing F3, F5 first and then F2, F4? It really doesn't matter as long as you're looking for the optimal merge pattern because they're two independent events. In actual real world systems, when you implement something like this would happen on one core, this could happen on another core. Right? So these two can happen simultaneously. Again, this can also happen simultaneously because there are no dependencies in the real world. Right? So that could be the cause of confusion, but the most appropriate answer here is B, obviously. Right? I hope this is clear, right? Again, you just have to be careful with parentheses. That's it. We've solved a lot of these types of problems in our course videos also, so this is straightforward. Here comes one of the interesting problems of the day. Remember, it's an MSQ. Please take your time to solve this carefully. I really enjoyed solving this. Yes, the previous one was a greedy algorithm, as I mentioned when I was explaining the solution. Yes. This is standard Dijkstra's algorithm. Very nice problem. Please be careful with this. This is a good 2-mark question by GATE standards. Remember, it's an MSQ, so you have to be careful there. Remember that you are using Dijkstra's algorithm here. Please be careful. Let me give you a hint. Please apply Dijkstra's algorithm on the given graph. Carefully, just go line by line with the code that you know. I mean, do it carefully, please. That way you can avoid the obvious traps in this question. I told you that this is a good question because it has a lot of traps. Again, this question is based on a 2012 question in GATE CS, but we have modified into an MSQ, made it slightly more trickier than what's there in 2012. It's not the same question, but it's inspired from that question, and one of our mentors actually improvised on top of it. Please apply Dijkstra's algorithm on this graph. The question clearly says that you are applying Dijkstra's algorithm on the graph with vertex S as the source, and you want to find the shortest path to vertex 9. As expected, a lot of students have made mistake in this problem. That's why I've given you hints, which is, it's an MSQ, be careful. There is no point in Googling a question and trying to get it, but yeah, let's solve it. Anyway, I'll explain the solution in a few minutes. This is a hint. Yes, let's solve this question. It's a very nice question. And then we'll wrap it up for today. This question is not hard. This question is medium plus tricky. It's intentionally made tricky by us. Okay, I'll wait for a few more seconds and dive into the solution itself. Okay, so let me get into the solution in the interest of time. Some of you, especially those who have answered it very quickly, they probably just say, hey, what is the length of this path? S1, 2, 6, 9. Okay, they got some number. Then S3, 7, 9, they got some number. And they said, okay, all three of them have the same path length, so that should be the answer. No, here it clearly says that we are applying Dijkstra's algorithm. If you apply the brute force algorithm, imagine if the question said, it did not mention about the specific algorithm. If you apply the brute force, if you look for all possible paths between S and 9, then probably the way you implement a brute force algorithm, multiple options can be correct. So let's apply Dijkstra very carefully here, right? So you're starting with this node. Initially, the distance to all the nodes, again, this is something that we explain in lots of detail using the CLRS pseudocode in the course videos. So initially, everything has a distance of infinity, right? That's how you initialize it. And from here, let's start relaxing the edges, right? So we extract this. Of course, the distance from source to source itself is 0, obviously. Then you relax all the edges that are there, right? So you relax this edge first, right? And the distance to vertex 1 becomes 1, right? And the distance to vertex 3 becomes 5, okay? The distance to vertex 4 becomes 2. Again, I'm applying Dijkstra's algorithm step by step, okay? And then now what do? You place all of these into a min heap, and then you extract the minimum from the min heap. That's a standard Dijkstra's algorithm process, right? So let's apply that step by step. Now, okay, so S is now done with. Now you have 1. So you have vertex 1 with a distance of 1, you have vertex 3 with a distance of 5, vertex 4 with a distance of 2. Now what do? You pick the minimum, because you're doing extract min, right, from a priority queue. So when you do an extract min from here, you get this, right? Now, after you get this, you now relax all the edges corresponding to it. So there is only one edge here, so you relax this edge, and the distance to vertex 2 becomes 1 plus 1, the distance becomes 2, right? So now this edge is processed, you're done with this, so let's just tick it for a while, okay? So you've already relaxed all the edges connecting to this. Now we are left with vertex 2, vertex 3, vertex 4, right? Distance is 2 from source, distance is 5, distance is 2. Now we will extract min. Now there is a small confusion. When you extract the minimum weighted vertex, will you get vertex 2 or vertex 4? Right? So vertex 2 versus vertex 4. In Dijkstra's algorithm, that's what you do, right? You iteratively extract the minimum till the time all vertices, everything is covered, right? Now here, which one do you get? It could be anything based on the implementation of your priority queue. Again, when you do extract min for Dijkstra's algorithm, whether you extract vertex 2 or vertex 4, the answer will be the same. Okay, you can verify that. We verified that. So let's assume this is extracted just for the sake of simplicity, but the solution will not change whichever answer you do. Now once you extract this, then you relax all the edges corresponding to it, right? You relax this, right? So for vertex 6, okay, let me just draw it carefully. So for vertex 6, the distance will now be 7. For vertex 7, the distance will be, so you relax this edge, this will be 9. Till now that's the case. Then this is already relaxed. So all the edges from it are relaxed, so you're done with it. Now what all vertices do you have in your priority queue? Vertex 3, 4, 7 and 6. Which has the smallest? Obviously this has the smallest. Right? This has the smallest distance right now. So you relax all the other edges. So you have this edge that you'll relax. So to vertex 5, you will say the distance is 4. So this is relaxed now. Simple. Now what all vertices do you have in your priority queue? This and this. Now then you extract the min. Right? So when you extract the extract min from the priority queue, you get this. So you get 4. Right? So then you have 4 plus 5 equals to 9. Right? How does Dijkstra work? So the distance from the source, the best distance we have found till now from the source to vertex 5 is 4. If I add 5, I again get 9. I already have a path which is 9. So there is no point in updating the path. Right? That's very important. Right? You only update the path if there does not exist an another path. See, there is already a path from source to vertex 7 of length 9. Even if I go through source 2, 5, 7, it's again a length of path 9. So I can just completely ignore that because I did not find a shorter path, right, in this sequence of events. So this edge will not be taken into consideration and no updates will happen here. Even though this is relaxed, remember this is relaxed, but this will not be part of your shortest paths, number one. The other thing, so let's go to the next step now. So this is processed. Now you have this. Right, here also you have distance from source to vertex 3 is 5. 5 plus 4 is same as 9 here. So there is no advantage in creating this edge. There is no advantage in creating this path because its distance and this distance are the same. So you will simply ignore this. That's how the Dijkstra's algorithm typically works, right? Now, okay, so now you're done. So this is also resolved. This is resolved. Next, which is the shortest? Which vertex in your priority queue has the best value? It has this 7, right? Now let's start relaxing. 7 plus 4, you get 11, right? So to this vertex, you get 11 here. So this is your edge. Okay, next. Okay, so this is done. Then you do 9 plus 2. 9 plus 2, again, that's how your priority queue works, right? First you finish the vertex whose distance is 7, then the vertex whose distance is 9. So 9 plus 1 is 10. So the distance to this is 10. Very good. 9 plus 2 is same as 11. So there is no point in having this edge in the path. There is no advantage in doing that, right? Number one. Next. Okay, so 9 is also done. Now we are left with only two vertices, 10, this vertex 8 and vertex 9. Now if you relax this, again 10 plus 1 is 11, but there is no advantage in having this, right? So, I mean, of course this edge will be there. There is no advantage in having this because it's not reducing the distance in any way. Now, if you use the predecessor path, right? If you use the predecessor path, you'll get S to 1 to 2, S to vertex 1 to vertex 2 to vertex 6 to vertex 9. That's how you got this value 11, right? So this path. While there are other paths that will lead you to the same distance of 11, in the standard implementation of the Dijkstra's algorithm, they will not pop up, right? So there might be other paths here that have the same distance 11, but they do not get popped up because you are using Dijkstra's algorithm. So only option A is the right option. Again, this question, as I mentioned, is based on a 2012 question, which was not an MSQ. It was an MCQ, right? Here we created an MSQ, and to confuse you more, we gave multiple paths. The way this graph has been designed carefully was this graph has been designed keeping in mind that people will make silly mistakes, right? So again, you can get this exact path by getting the predecessor. Again, there will also be a predecessor to every vertex. So predecessor to 9 will be 6, predecessor to 6 will be 2, predecessor to 2 will be 1, for 1 will be S, right? So you just do that. So it's a simple but a tricky question, and nonetheless an interesting question for GATE, right? Cool. Sounds good. So let me change to the webcam view and let's get into the general questions. Let me just pick up my phone. I believe some of you posted general questions earlier. Please repost them. I'll try to answer as many as I can. Okay, cool. Okay. Again, I think somebody asked a question. I'm just trying to recall questions that were asked earlier, which was, I've completed CN, which subject should I pick? Now, you can pick any subject, but what we often recommend, again, we have multiple videos on that on our YouTube channel also, which is try and pick a subject which is scoring, like TOC, compiler design, DLD, etc. Because those subjects questions tend to be slightly on the easier side in GATE, more scoring. So that's the order we suggest students, but of course, students have the liberty to pick any subject of their choice. Since you have completed CN, go with any subject, that's okay. But it's always preferable to cover subjects which are more scoring first. Cool. So somebody, Aman, says, I'm scoring 70% in practice questions. Very good. You're doing very good. Just make sure you're consistent. Try to push towards the 80s, because make sure you're debugging your silly mistakes. Just be persistent and consistent in your preparation. You stand a very good chance as long as you're persistent in your preparation. Cool. So I've completed DSA math. Should I study TOC CD or digital logic? You won't go wrong with any of them. TOC CD tends to be a slightly larger subject together than DLD. So you won't go wrong anywhere. Since you already done math, probably doing TOC is better because it's also in the mathematical flow of things. So somebody saying, is Aloha and cryptography part of the GATE exam? I think Aloha has always been part of the GATE exam, if I'm not wrong. There were some concepts from network security and cryptography that were added last year. We created the corresponding content for it last year itself. Again, some other concepts were removed from some aspects of computer networks. Yes, some aspects are there, not everything. That's the key there. So KD says, please provide printed PDF with images and illustrations. Again, it is fairly time taking to do that. We would like to do it, but it takes a lot of effort, and our priority right now is to help our students get through the questions. We believe handwritten notes for those students who are solving or who are going through the course videos, just the hand notes is sufficient for most revision. Of course, we strongly encourage students to write handwritten notes, and if there is somebody who can collaborate with us to create high quality illustrations and like PDF notes, we would like to collaborate. But as far as our mentor's time is concerned, we thought it is better put resolving students' questions. We get like thousands of questions nowadays, and we are better off solving that than just spending a lot of time in creating illustrations at this point of time. Okay, cool. So I got 2021 pass out. I got 2836 and an offer from a mid NIT and from Cognizant at 4.5 LPA. What to choose? Okay, very nice, very interesting conundrum. I would say the mid NIT that you got, just look at the placements that they have. If let's assume the top 10% of the class are getting good placements, then you can comfortably join in the NIT and work hard in the 2 years to be in the top 10% of your batch. That is, I mean that's perfectly all right, because in the long run, nobody cares which NIT or which IIT you come from. it is your skills and the most recent work that you've done that matters. So just look at the placements at that specific NIT. Again, if you're placement centric, I mean, that seems like the most logical choice. Again, you can always email us with more specific details that you may not want to share on a public forum. You can always email us and our team can get back to you with that, with some more data. Okay, I think somebody asked about CN, which I answered. Okay. Again, to be honest with you, somebody is asking why are you choosing voice over mode versus video mode? The simple fact is video sometimes is a distraction, not always, sometimes it's a distraction. We wanted our teaching to be such that it's as if a friend is sitting next to you, taken a notebook, and he or she is trying to explain you the concept. That feels very personal. Again, it's also, again, to be honest with you, that's also faster to create more content. Remember, Gate has like almost 400 to 500 hours of content. And we created most of this content in like 7.5 months of like literally 16-hour days when we first launched it. Of course, we've been constantly improving the content, correcting mistakes and adding new content as and when needed. But we thought like having a friend sit next to you and explain it line by line, we wanted to simulate that effect. Again, there is no one right or wrong. We can do like a full graphics type of thing, but that takes so much time. We thought it's not worth the effort as compared to having something like a friend sit next to you and explain it on a piece of paper, as long as the concept is clearly explained. So we went more for clarity of explanation rather than just putting in some fancy animations. So that's been our core philosophy. Again, we have been very much inspired by Sal Khan, the Khan Academy and things like that. That's been a fundamental source of inspiration for all of our co-founders and team, including myself. Okay. Is 65% enough for IIT if you get a good GATE score? I think that should be all right. I think for some programs, universities might say you should have first class, but for a lot of programs, they don't even care what your undergrad marks are, as long as you get a good GATE score. You don't have to worry about it. So somebody says, what happens after we complete research? So let's assume you finish your PhD program. You typically have two options. One, you go for a postdoctoral degree at a top university under a good professor, and then you join you join academia as an assistant professor at top universities. That's one standard path that people take. The other path is you finished your PhD and then you go join one of the top companies as a scientist, typically in a scientist role. Typically, some of them join also as into engineering roles because some companies may not have pure research roles. So I know people who have done PhDs from top universities go on as machine learning engineers, data scientists, machine learning scientists, research scientists, all sorts of things. So that's a typical career path. Cool. So how is the alumni network of IISc compared to old IITs and BITS? Again, the alumni network at IISc is a very different type. Like it's very different because we don't have the undergraduate population. We don't have like the thousands of students that IITs or other universities might have. So in the research community, it is very, very good. So for example, if I have to reach out to a professor and who is an alumnus to work with, or if I have to reach out to somebody at DRDO or ISRO who is an alumnus of IISc, we see a lot of top people in core research domains. We also have people in the industry, but certainly because our batch sizes have always been small, like my batch size was 25 or so. So in the CS, right, as compared to an IIT who has like hundreds of students typically. So because of our batch sizes, the network is smaller and it's more skewed towards research rather than typical non-research roles. Again, the alumni network is okayish. It's not as tight bound as, let's say, IITs, to be honest with you, just to be clear there. Can I download the attached spreadsheet? You can download it. Most likely we'll try to stick to that, but it's a Google sheet, so you can continue. There might be minor changes here and there. Let's assume I'm not able to do it on a specific day. We might move it here and there. Okay, so sounds good. Again, the schedule is there in the sheet, in the chat window. We have pinned it at the top. Please check that. So Kiwi says, I'm feeling a little overwhelmed to keep up with the flow here of the subjects that we're doing. That's okay. Everybody has their learning speed. We are trying to complete all of the subjects by sometime in October. If you're not able to keep up with it, that's okay. It's perfectly understandable. Some students might need more time. Just schedule it such that you at least complete it by mid-December or late December. That's also perfectly okay. Don't be in a rush. Try to understand whatever subjects you complete. Try to understand them well, practice them well enough. So the schedule that we have created is to complete it by October, at least the first iteration. If you're not able to follow it, that's perfect. We understand that. We've had a lot of toppers who could not follow it last time because of various constraints. And some of them finished it even in December, early Jan also. That's okay, no problem. Cool. So what to do when you're lagging behind from the schedule? You have two options. One is if you're lagging a little behind, just try to make up for it and start with the next subject along with these live sessions. If you're falling significantly behind, you can probably skip that subject and move to the next subject if you can do that. Or else you can just go with the flow, ignore these live sessions. You can do these live sessions a little later because they'll be available. If you're a course enrolled students, all live sessions will be on the course page. If you're not a course enrolled students, all the public live sessions will be on YouTube. So you can just go through these live sessions at a later point at your own pace. Cool. So how to improve math? I think this was from Yash. I mean, there is no other alternative just to solve and debug, right? Ask yourself, I mean, it's a very common thing that people say, I'm weak in math. But when I ask them why, what part of math are you weak at? Most people can't answer it. So what is important is you have to debug what you're not getting. And even most of the math content that we explain that through problems. The engineering math and discrete math, most of it, if not all of it, we try to explain it through problems so that you build that problem solving mindset. I think that's one of the best ways to learn math, which is take a problem, while solving it, you learn new concepts. Then you know where a concept is applied, how it is applied and things like that. So, I mean, there is no escaping that practice part. Again, we have had students who are very bad at math who picked up through sheer practice and going through the videos. Sometimes the problems that we solve in the videos, they pause it, they try to solve it themselves and then watch the video. That's also a great strategy that you can employ so that you know what you're lacking. That's the most important part, is with any subject, specifically for math. Somebody is asking, can you make a video on comparison of BITS versus IIT? I think at a master's level or a PhD level, IITs are way better than BITS, hands down, no questions about it. BITS undergraduate programs are good, but not their master's program. I think a lot of NITs and IIITs are way better than BITS master's programs, both in terms of their course structure, course curriculum, and in general faculty and things like that. When can I start test series of applied roots? It's already available. You can enroll for the test series and start it right away. Right? All the topic tests are there, and we have a schedule for all the subject tests. Multi-subject tests, grant tests. There's a defined schedule. You can go to our website and check it. Cool. Again, somebody says live sessions are what keep me track. Very good. I mean, the whole purpose of having some of these live sessions is to be like a holding hand for students to help them stay on track of their preparation. That was the whole reason why we started live sessions in the first place. Cool. What should I do first? Applied gate test series or PYQ? You won't go wrong doing either of them. You can do either of them. That's perfectly all right. No, there is no worry. You can do PYQs for the last, let's say, 10 years and then do applied roots test series or vice versa. Both of them are very good for your preparation. You won't go wrong with either of them. Just make sure that you do both of them. That's all. If you're trying to do both. Because most of the formats of questions in the last 10 years, we anyway have them covered in the applied roots test series. Even some new formats that are not there, like some of the problems that we have seen today, right? They've not been, like the first question today, we have not seen similar questions in GATE earlier. So it's a completely different format. So we try to come up with new formats, taking inspiration from standard textbooks. But even if you just solve applied roots test series, most of the formats of top problems in our last 10 years of GATE would have gotten covered in that. Again, anybody who is scoring 40+% marks in practice tests, you are on the right path. Debug your mistakes and keep going to a better level. As long as you are like in the final exam, if you get 70, 75 marks, you are like one of the toppers, right? So don't worry about it. Just make sure, even if you're getting 70, 75 marks in the practice tests, to take the topic tests to see where you're lacking, to debug your mistakes. That's the most important part. Even if you're getting 90 marks, I would say debug your mistakes. That's the key. Most importantly, people who are getting good marks, like 50+% marks, please be consistent, don't give up. The biggest problem we see with students who get good marks is they get cocky, they get overconfident, and they stop their preparation, or they slow down their preparation, and everything goes down the drain from there. So somebody says, I can't solve most of the PYQs in a constrained time environment. How do I improve? You don't have to worry so much about it. To be honest with you, at this point, even though we are in July, don't worry about time constraint solving. That will come when you solve like 2000 problems eventually. You will get that. That's not a problem at all. The most important thing is getting it right at this point. You can worry again from between now and let's say December. If you solve 2000 problems, your speed will automatically improve, right? So don't worry about speed right now. Look at accuracy. That's the key. Yes, somebody very nicely says, this is Deboshmita, who says GATE feels like a marathon. GATE is a marathon. It's not a 100-meter sprint. It's a marathon. It requires a lot of patience. And I know this firsthand because I used to run long distance earlier in my life. And of course, I've stopped it long back, unfortunately. But it requires a very different mindset saying, okay, this is how I pace myself. You cannot burn out yourself. You have to pace yourself till the last minute. It's again the biggest reason that a lot of good students, a lot of smart students don't crack GATE is because they're not persistent. Just like in a marathon, you have to persistently run. Of course, you can take a short slowdowns and breaks, but the preparation has to continue, just like a long distance run. So somebody says, can we skip GNF and CNF of TOC? Why? It's a simple topic, right? Right, CNFs, I mean, in compiler design, etc., they're fairly simple concepts. Why skip them? They're very scoring, right? So I would recommend against skipping it. So will applied AI course help students build research papers? No, unfortunately, we are not geared towards core research because that requires, again, this is about applied AI course, not GATE. In applied AI course, our focus has never been core research because that requires a completely different setup and mindset, very different type of education. We are more focused on getting our students good careers. That's always been our focus. Like if you want to go write good research papers, I think you should go to top universities because they have a system of publishing research work day in, day out. We are not the best place for it. I mean that's how we have designed applied AI course from the very beginning. So a very nice question. Jatin says, after breaking consistency, how to bounce back? It's a very nice question. One technique that I personally employ is like if I had a few bad days where I didn't work to my fullest or I think I did not do a good job, I make the plan for the next 1 week beforehand. And I say, I'm going to rate myself for the next 7 days and I'm not going to give up. And every day I do a good job, I give myself something interesting, like for example, a good fruit juice or something that I like, right? That's what keeps me sometimes motivated. Again, it seems like a very simple life hack, but it works. So always plan before day. If you're planning for a week, do it in the weekend so that you try to stick to it. You have to put in that extra effort for the first 1 week to get back on track. It is always hard. Suppose if you wake up at, let's say, 8 a.m. every day, waking up at 5 a.m. is very, very hard. But you have to make sure that you drill it in your head the before day night that yes, I'm going to wake up at 4. These are my 4 alarms or 5. It could be 4 a.m. or 5 a.m. These are my 4 alarms. I'm not going to switch them off. I'm going to put my phone very far away. Do all the standard things to get back to work. And slot your time. Again, we have a full video on our YouTube channel. Slot your time into 90 minutes windows. Be focused. Try to give your best in those 90 minutes. You struggle for a week, it becomes a norm again. Okay, cool. It's a very common problem. Cool. I think some of our mentors also have answered most of the questions here. If I start GATE preparation today, can I get good marks? Yes. So a lot of GATE preparation actually starts in July and it actually gets serious only from September. Again, you can look at a lot of toppers from the last years. We have some of those interviews on our YouTube channel. Many of them started their preparation in July, August, and they actually got serious. Again, GATE preparation requires 6 months of good effort. If you put in your mind and soul and heart into it, if you're disciplined, 6 months is sufficient to crack GATE. To be honest with you, that's all you need. So you have more than 6 months if you start now. It's still a very good time to start. I would say as long as you're starting before October, I think you're on a good track. If you're starting from October, I'm going to assume that you've already written GATE once, or you know most of the concepts, or you're pretty decent with problem solving. Then you can crack it even if you start in October, but there are fewer students statistically that we see who do that. Okay, sounds good, folks. Let's wrap it up for today. We have another session on Friday where we will not discuss about GATE specific stuff. It will be a more general session about interview prep using the concepts in data structures and algorithms and how to tackle some of those interview related problems. Okay, see you on the Friday. Bye.